Generally speaking, a vertical asymptote is where there are vertical lines where your denominator is 0. And since your denominator cannot be 0, these are vertical lines where your graph will never be. For example, in this graph here, what it looks like, it's represented by this dotted line here. And you have this graph that goes to infinity downward and to infinity upward, but it can never touch this x value right here. Therefore, this is a vertical asymptote. Now, how we find them, the first step is to set the denominator equal to 0. So if we have the function x squared plus 2x minus 3 over x squared minus 5x minus 6, we really don't care what's at the top. That doesn't matter for our purposes here. But we take the denominator, the x squared minus 5 minus 6 part, and set it equal to 0. So we get this right here. Next we have to solve for x. In this case, we can do that by factoring, and you end up with x minus 6 times x plus 1 equals 0. And then we have what's called the zero product rule, which means that if you have something times something times something, or however many somethings you have, equal to 0, that means each of the somethings are equal to 0. So in this case, x minus 6 is one thing, and x times x minus 1, or x plus 1, excuse me. So because of that, we can say that x minus 6 equals 0, and x plus 1 also equals 0. So we end up with x equals 6, and x equals negative 1. Therefore, at x equals 6 and negative 1, we have vertical asymptotes. Remember, we just took the denominator up here, set it equal to 0, and solved for x. And those x values are where the vertical asymptotes. For example, this is what that function looks like. This is really a pretty bad drawing. It's out of scale, but hopefully you get the idea. Right here, if this was our negative 1 x value right here, we have a vertical asymptote, so it'll never touch here, and it'll never touch going down there. That extra line isn't supposed to be there. And we also have one at 6, so if this were x equals 6 right here, this is the vertical asymptote, and this will get closer and closer to there, this will get closer and closer to there, but there is no part of the graph on x equals 6 on this vertical asymptote. So as a general note, if you have a function with multiple pieces, you have to look at both of them. And what I mean by that is, for example, in this function, you have 1 over x, and you have another piece that's 1 over x plus 2. You have to figure out where x is 0 for both pieces. So you have to set this denominator equal to 0 and this denominator equal to 0. So we end up with x equals 0 and x plus 2, which gives you x equals 0 and x equals negative 2, which would both be the vertical asymptotes for this particular function, because you took all the denominators that you had and set them equal to 0. However, I just want to show you a different case where you have two pieces. You have this 1 over x plus 5 over 2. You want to take the x here and set it equal to 0. However, with this one, it's just a constant. There's no x in it, there's no variable, it's just a number. This has nothing to do with our vertical asymptote. It'll influence what the graph looks like, but it won't change our vertical asymptote. So we don't care about this because it doesn't have an x in it. So therefore, the only vertical asymptote in this function is x equals 0 that we got from setting this denominator equal to 0, and it was already solved as is. So we got that.